Alrighty, how's it going, everybody? Good morning. Welcome to Saturday of Siege. I'm excited to be here. So today I'm going to talk a little bit about my work at Army Game Studio on a game we just finished up called Decide Delete Emergency Command. What exactly? Well, first of all, I'm Ryan. So yeah, I'm a game developer at Army Game Studio, and I'm a programmer designer at Lazer Bread Games as well. You can find me on Twitter at Lazer Bread Ryan down there. So I'll have that link up later too. But let's talk a little bit about Decide to Lead. So Decide to Lead, what exactly is this game? So what we were tasked to do basically for our Army customer was to capture the experience of Army leadership in a game. And they had some other games in this franchise that were in VR and some other things. So, but this one they wanted to build a game for a 65-inch touchscreen table that they're going to use at conventions and things of that nature. So we needed about a 10-minute play session, and they gave us about originally like 6 months, but we got it extended to about 9 months due to all the kind of difficulties that we had. So the initial design was kind of a resource management card game with a tilt toward kind of the action-oriented game. And then we took a lot of iterations on that design to work in more things like communication, teamwork, and leadership to kind of try to reflect some of the values that we were trying to capture. But it was not the easiest thing in the world. We had a lot of difficulties, as I'm sure you can imagine, doing a production like this in current times. So we were removed from our office only a few months into production, which was difficult, especially when trying to test on this device that we couldn't have access to. Our team fluctuated a lot throughout the process. We had designers come in kind of late, and even the same designers leave early, and we didn't really have a full staff on that due to other concerns at the studio. And so that and the cultural relevance of the game was hitting pretty hard, especially when if you look at the game, we'll have things like a virus outbreak level or wildfires in the game. And so a lot of this stuff we had to handle carefully, and that was another concern that we had. So a lot of these things came up and made this a very interesting project. But all that said, let me show you how far we got in 9 months. So this was the game in December of 2019. So you'll see like very basic play here. Like we have some cards, they have values, you put them on missions. It's a really simple kind of setup. And that's basically what we had for a prototype. And then within 9 months, we got to here. I'll just let this video play. It's kind of our trailer for the game. That would be a problem. Okay, well, we'll move on without the audio for that. That's fine. But you get the idea of where the game's at this point. So that's kind of what I was trying to capture. So we'll just go ahead and move on from there. I don't have any other videos, so full screen that again. Oh my goodness. Sorry. To do that. All right. Apologies. Okay, there we go. All right, so that's the game in its current state. So sorry we didn't have audio there, but it was mostly just music anyway. So you kind of get the picture of what's going on there. So that was 9 months of work, and we can kind of talk about how that was able to happen in 9 months, because it seems like a big jump, right? And specifically, I think in this talk we're going to talk about how our game engine architecture enabled this. So we're going to focus on some things that went really well with our game engine architecture, specifically planning, reusing different scenes and behavior, and tweaking the gameplay, and things that didn't go so well that we had trouble with, like mapping a gameplay to our level, too much prototyping, and too much or not enough building tools. And then in the whole thing, we're going to wrap this up and then have some nice notes for other intrepid developers like yourselves. So first off, plotting the course, right? So what do we want from our game's architecture? Our last game was U.S. Army Stars Anatomy. It was a mobile game, and we had some serious architecture issues in that game, even though it was pretty successful, but we had some problems managing a lot of things. For example, we had about 40 scenes plus, and changes in one scene could break another scene, and often did. And I think we still have some minor bugs today in that game because of these problems. We didn't communicate very well, and I think it's important to talk about communication in an architecture talk, because your game's architecture is going to take on the framework of the communication that you use. So there was a lot of problems communicating in that game, where we had these different silos of the game that were all kind of being developed in parallel, but there wasn't a lot of crosstalk between. So we wanted to kind of address that. And then so we also took a long time iterating on different parts of the game, just because we didn't know exactly where we want to go. So a similar scope of game ended up taking us a lot longer than what we ended up doing in Decidedly, just because of how much time it took us to find the right answers, right? So when we were looking at starting Decidedly, we were like, okay, what can we do to address some of these problems, and how can we make a better plan for this game? And that's when we found Ryan Hippel's talk, Ryan Hippel from Shell Games at Unite 2017, where he talked about scriptable object architecture in Unity. And this was really inspiring for us, and it started to make us realize, hey, what if we could make changes without breaking a bunch of things? What if we could test our code on the fly? And what if we could, the biggest thing, write less code, right? Because if we write less code, we'll have less bugs and we'll have less things to test. So the big experiment started with a gajillion hours of design meetings, and we really had to set up a course before we set sail on our task to build this architecture. And those meetings never ended, because it's important that you keep communicating about how the architecture is working and how it's not, as you kind of go through this process. And I think if you keep meeting and you keep talking and you keep being honest about it, you're going to dig yourself into less holes, and you're going to write less code you don't need. And we talked about how that's a benefit. So let's talk more about writing less code. Some common code reuse practices and stuff that we used a lot in Anatomy were inheritance, where you might have some code, some class in another scene that has very similar functionality to what you want, but you need an additional thing or a slightly different thing, and so you inherit from that class and you implement it here in this other scene. Virtual functions, which is a type of inheritance framework where you might have these functions that exist at the abstract level, and then they're just used across the board in multiple places. And you could use singletons for siloing your logic into one big class somewhere, and then passing things to it and stuff. But we had some trouble with a lot of those, and they were kind of the root of our problem in Anatomy. For one example, we had a skeleton bone selection system that we inherited from in multiple scenes, 3 different scenes. Every time we would change that in one scene or another, it would break all the other scenes, and that was one of our key problems. So we started talking about better ways to reuse code, and we started talking about, okay, can we aggregate things together so that we just have more lists of things to operate on and less monolithic classes? Can we compose together behaviors that we can reuse that are simple? If you've ever heard of the solid methodologies, it's kind of coming from that. So if you haven't, you should look into it. and how maybe we can decouple our behavior from each other so that we have very simple behaviors that we can then add together to make a full thing. And that's the first step in separating also the data from the logic, which is going to be a core tenet of this talk. So let's talk about applying those solutions to our game. So like I said, the key tenets of our architecture, we're going to separate behaviors from each other. We're going to separate the data from those behaviors, and we're going to allow for minimum iteration time every time we want to make changes. When design comes in with new stuff, we want to be able to, flip on our axis quick. So that's key. So 2.1, we using scenes as a black box. So how can we reuse scenes such that we don't have to make 30 of them every time? Because that's an easy way to have, different levels be broken when you forgot to put whatever it was in the 44th scene, So what we ended up doing was developing a system to run our scenes basically in a coroutine. So in an asynchronous way. We called this a stage. So essentially you can run a coroutine that represents the entire game sequence for the whole game. And then in that coroutine, load scenes and wait for them to load, get the stage out of the scene, pass it input, wait for it to finish, and then you might get output, and then you can pass that along. So as an example, you might have this level data represented by a scriptable object. You pass it into the level scene, it chews on that, players do things for a while. When you're done, it spits out a metadata report that you can then use to build like medals. And that's actually what we did in Decidedly. There's only one level. We pass in new data, we get out data to bake our medal system with. And it's been super awesome. So let's look at a code example of that. This is not the actual code from the game, but this is just kind of an example I mocked up. So you might have like a game state sequencer class. It could be a mono behavior. It could be a scriptable object. But the goal is this is going to exist above the scope of the scene. And so you can just run, in our example, the whole game in a coroutine. So you can say, hey, let's just start a coroutine and then await loading the scene. And then there should be a yield return for find objects of type .run, but so we'll run the scene and then we'll wait the scene's process before we continue, do some other stuff, and the game ends. And then what a stage would kind of look like is here, we inherit from a generic class called stage at line 18. I got a pointer, I could probably use that. So line 18, and then we also we just implement run, and we can give it data, and so we can do stuff like, hey, this stage knows about the metal animator in the scene somewhere, and it's going to wait for that thing to finish, and then we're going to wait for you to press a button, and then we could do stuff like, hey, here's a result that says you press the green button, which means you want to go back to this level or that level. So we can kind of control this, and it's almost like a linear state machine, and we'll get more into state machines later, but that really helps us sequence our game. And then so for timelines, this is an example of how we did that. These were our inputs into our level scene. So we defined the scriptable object with just hundreds of events sequenced in time. And then we would have specific breakpoints right here, these red ones that were like, wait for all the previous events to finish. So what we would do is we'd pass out this layout for a level to the scene, and it would run the whole game in a coroutine. So this is like 10 minutes of content represented by nested versions of these scriptable objects that just run and essentially list out the whole game. So that's kind of awesome. And another thing just to mention about running this game asynchronously, there are a lot of ways that you can do this as far as setting up a larger system outside of your scenes that controls your game state. In another project I'm working on, we use an ink script to control the overall game state instead of a coroutine. And I think that there would be a lot of advantages to using a fully realized state machine to control your game state. For our example, a coroutine was the simplest way, but I think the main takeaway from this is that You can use your scenes as a black box, and you can sequence their execution however you see fit, and that will help you a lot in keeping things clean and orderly when you're running the game. So let's talk a little more about finite state machines. That way we can show how we reuse behavior there. So you have the classic behavior reuse of just reusing mono behaviors, having nice mono behaviors. You can reuse those components. But we also have smaller behavior, like if we have a card and we need it to go into a state where we can interact with it, but sometimes it needs to go into a state where we can't. Those are a little bit smaller than the component level, but those are behaviors that we want to be able to reuse. And so an FSM is good for that. And an FSM is basically, if you don't know, it's just a graph of different states an object can be in, and then you define transitions between those states. So there might be like 10 states, and there's different ways in which they can go from one to the other. And there are a gajillion ways to make an FSM. But we specifically wanted to make one that was really easy to write. We could reuse behavior super easily, and it was going to give us enough performance to allow us to have thousands of them in the game at once. And we did end up having about that many, because our FSM was used for all the missions, all the cards, all the units. So we have like hundreds of little navmesh guys running around. They all are running in the same FSM. Our trainers, is everything in the game for the most part used an FSM like this. So let's look at kind of a code example of that FSM. So this is how we would construct the FSM. So you might have you'll make a new state machine, and you would give it 2 enums for like the different states you would have and the different triggers you would have. And so whenever you wanted to make a new state here on line 8, you would just basically define new state, and then we have 3 actions that you can just subscribe to, basically. Enter, update, and exit. And you can just anonymously assign a delegate to that, which is super clean and easy to do. So now the way C# works, we can capture data from the parent class here, so we don't need to worry about setting all that up. We can just start using stuff that's in this mono behavior right inside that code block. So it's really nice. And then if we don't need to define the code block, we don't have to. So we just have, here's an empty state. That's one line, which is kind of nice. And so when we add these behaviors to the graph that we're making with the FSM, we basically call add state, and then we use, maybe states has an enabled value. We say, okay, enabled is going to be my cool behavior, and then this is the really cool thing for code reuse, dot union initialize state. So what we're doing there is we can compose multiple behaviors together and return a different state that is just those things basically stapled together. So now whenever we enter enabled, it'll call enter on my cool behavior, and it'll call enter on initialize state. And we could do that as many times as we want, as deep as we want, nest that, yada yada. So that's been super helpful. So if we ever want to write like a disable the graphic state, we write that once. We don't have to write that again, which is awesome. And as far as transitions go, really easy API for defining those. You just say, hey, I can go from disabled to enabled if you get the trigger enabled. And then whenever you set triggers, you basically just call fsm.setTrigger, and you can do that all internally from the class and expose kind of public API for that. So this was a backbone of, I think, pretty much the entire game, and it's something we've planned to reuse, and we are reusing in the next games. So moving on to 2.3, something we have all affectionately called data nuggets. Who would have thought to serialize a float, right? So let's talk about that. In Ryan Hippel's talk, he talks about their variable implementation, where they have scriptable objects that represent a single float value, a single int value, a single bool. We thought that was pretty neat, and we wanted to try it out as kind of an experiment. And what we found was it was actually super awesome. So when each variable is its own asset, let's say you have a float for card flick speed, right? You can when you change that float, if that's assigned as references to all the different card prefabs, scenes, etc., then you can then get change propagation happening throughout your whole project just by changing that one value. So that's really cool. You can also assign more than just the float value to these assets. we assigned metadata string. So we have like some data about, hey, let me explain what this float's doing. So now we can like print these reports out and do things like have tooltips in the editor that show us, oh, this thing is made to do this specific task. And then we also could do things like debug and release configuration where depending on what mode we're in building the game, we could pull a different value from those assets. So that was awesome. We did this for floats, ints, colors, bools, curves, all kinds of stuff that we could then, organize a little bit better. And another thing we did with scriptable objects that was really cool was enumerations, and he talks about this in the talk as well. But having essentially, like, for an example, we had our card types, which were like, the different colors, different MOSs of different teams. So we had like 8 of those, I think, that you could either play as or train into. And for those were all just assets of a certain scriptable object type. And then they could have all this other relevant data cooked into it and then still be used for comparison. So if we're like, hey, did you play a blue card here? We could just check if that enum was the blue enum or not. But we could also have like color information, icons, names, stuff like that we want to pull out and then use in visual effects when stuff happens. That was super cool. And then finally, another huge proponent for the scriptable object stuff was a scriptable object event system. So, you might have a normal event system might look like some static class somewhere that you call publish, and you publish some message, and then other things listen on that channel for messages and then do stuff. And then that's a common way to decouple systems together. Just post something, and then some other system subscribes and hears it. So, but in this way, with scriptable objects, those can be references in the inspector, so that you can assign, we call them game events. You could assign a game event to an inspector field and then either publish to it or subscribe to it on enable and on disable, and then get this functionality of really decoupled, nice events. And we can look at kind of what those look like and also show how you can build really awesome tools when all of your assets are like this, when you have different things like floats and enumerations and events all set up as their own assets. Now you can make an editor window where you just fire the event during gameplay. That was incredible for us. And then our game events are generic, so we can put in our own arguments. And so we made this little window to let us establish what we wanted to put in the arguments when we fired it, and that was awesome. So the tooling kind of opens up possibility-wise when you do this. And then, more about data nuggets. Check this out. This is in the build, on the table, in the game. So we can open up this little dev menu, and we have literally like tens to hundreds of different variables we can tweak. We can try it out. We have presets down there where we can load specific presets for a bunch of different variables. We have different lists. We can organize it how we need to. This has seen a lot of iteration before our next game, but this system was absolutely crucial for our remote work times that we were in, just because we only got to this table once every week, maybe near the end. So being able to try stuff out and then change it, and it's great. So huge boon there. So let's talk about what didn't go so well now, because I showed you kind of the things that we really liked, but there were some things that we struggled with. So tools is pretty much what it all boils down to. We struggled to identify good pipelines for content creation, and at first our architecture really got in our way, because all of a sudden we have 100,000 files in the project, and they're all random, like floats and bools and integers and stuff, and it was just chaos. So later we realized this is actually really good for our architecture, but you got to know how to use it. And we didn't really think about the designer workflow up front, and there's some reasons for that, I think, based on team structure, but it was it ended up biting us. So just a note about tools in general that I think is important to talk about before we keep going is that, this isn't a personal project. We're working for customer requirements on a specific timeline. So we have a short amount of time to do this, and we have deliverables to hit. So there are heavy trade-offs that you have to make. You don't have infinite resources. You have limited time, limited money, and limited team, right? So how do you best meet the customer goals with that? So it's important that we talk about, with tools, how more tools is going to be a more complex project. You're going to have more testing you need to do, more things to document, more things to work on. That's just time sunk, money sunk, talent sunk. So you got to think, how are we going to reuse this? Will we reuse this? Are we going to reuse it in future projects? How polished does this need to be? So all of those are considerations when making tools. So it's not just as easy as we need to make the best tools we can. That's true, but we need to do that conscious of our context. So one of the biggest tools that helped us was a little package called Odin Inspector. And if you're using Unity extensively, you should 100% check this out. Odin Inspector, we would not have made this game without it. It was absolutely vital to making all the tools that we made and all the ways that we used our data. It lets you basically, instead of writing custom editors, you can define attributes that then juice up your editors and inspectors without having to get in there and write immediate mode GUI. It makes managing references a lot easier because they have a project validator that works with their required or validate input attributes to let you basically specify if an inspector field is valid. So required just says, if this is null, I'm going to throw up and I'm going to throw errors. And then you can run the project validator here. This is the project validator. You can run this and scan the entire project, and it will just give you a breakdown of every single place where your data is wrong. And then you can go in and you can change it. We actually wrote custom validators for this for our timelines, because I'll talk more about that later, but we had some real problems with those. So it's really great to be able to write custom validators and use this tool and also not have to worry about all these editor tools. I recommend it. I don't think you need to have this 100%, but if you don't, you really got to think about and get creative with how you're going to manage your tools, because this got us halfway there, for sure. So 3.1 of what bit us, not separating the view and the model. We got to get those graphics out of our gameplay. So we had some serious mapping problems. We had this island, city, place, and we had these missions that spawn, and they kind of related to the buildings on the island. So like you might want a helicopter to come up when you finish a certain mission, right? So they needed to kind of be in the same spot. But the 2D scene and the 3D scene really had nothing to do with each other, or shouldn't have, but we made them have something to do with each other. And we did that using scriptable objects. So basically when a mission tries to spawn, it has like a mapping of this is like a location asset it would have, and then it would look for that in the scene and then find it and then spawn the mission at that place. But that didn't go so well. So to talk a little bit more about model view controller design pattern, if you don't know about it, you should look it up. There's some other variations on this that are good too. But your model is the data that represents the state of your game. So it's just like all the different positions and numbers that represent the game, right? Like a mathematical model almost of your game. The view is one or more ways that that model is displayed to the player. And the controller is the part where the player interacts with the view, or interacts with both of them, and kind of is able to manipulate the model with the controller. So we had trouble here where the model and the view were smooshed because we were coupling them together. Our 3D visuals on the map had designated spots where our 2D gameplay would happen. And whenever we wanted to tweak the visuals or the gameplay, now there's this massive overhead where we need to tweak both. And it's just like this constant fighting the whole time. And to try to solve this, we ended up writing these validation tools that ran in the scene at edit time, and those corrupted our scenes. So that was terrible. But we figured it out eventually. But yeah, so that was rough. Here's an example of what I'm talking about. So you have the docked far left object selected in the hierarchy here. You can see it here in the scene view. We have gizmos for each location. So this location script exists on this object, and it has a locator. And these are location assets, and there are hundreds of them. And basically, whenever you make a mission in the timeline, you assign a location asset, and we do this like cross lookup to find where it should spawn in the scene. And that probably should have been something else. And you know, because this was so problematic, we ended up writing more and more editor windows, try to patch this and solve it and like make it better, make it usable, but it just never got there. I mean, we got there eventually. We finished the game, but this was never easy and was never going to be. So that was rough. Here's another example of me trying to make this work. So I had to put these like white spheres on the map that were about the size of a mission, and then try to like move them around so they didn't overlap each other. It was a nightmare. So that's for you. You should probably keep the view and the model separate. It's hard to identify where those things really need to be separated, but it's crucial to do so. And you know, don't be afraid to get creative with your editor tools. I think that we really could have benefited from making a tool that actually operated in the scene at runtime or in a scene at runtime to develop our game, and then we save that out, serialize it, and then load it. I think that would have been a much better workflow for us, because we could have edited the 2D map and the 3D map in parallel independently and not have them interact with each other. And also, never write validation code in your scene that runs editor mode. I won't say never, because you know, maybe there's some reason, but it for us, it null refed at some point, and then basically like eliminated hundreds of serialized fields. So you got to be careful with that kind of stuff. People should know that your code is doing things. If this is kind of in the background secretly running and like corrupting things, it's probably not good. That's kind of what happened. 3.2 of what bit us is we tried to prototype everything. And like I said, customers are waiting, so it's probably a bad idea. So you saw those cool knobs we had earlier. Those were awesome. But for the first few months, we didn't have a designer, and we thought maybe we could just do it ourselves with these tweaky knobs, and that began what I like to call the A/B testing fiasco. So we started to build systems with the idea of trying it both ways. So we were like, you know, what if they collided? What if they didn't? What if they did this? What if they didn't? We would build both, and we would have a Boolean in that menu to flip it on and off. We did that for like a whole 3-week sprint, just trying that out and doing things like that. And it just seemed so easy, but it got us nowhere because we had no context. We would test both things, and then we would go, I don't know which one's better. Wow, they both seem valid. And there's no definitive decision maker with no designer on the team at that time. So that didn't help us either. And it gave us like literally double, if not triple, the work, because we had to do both these things and integrate a way to change them. So it was rough. So notes for you on that. I think it's really important that you identify your entire team and their roles on day one. Multiple people can wear, like, or one person can wear multiple hats. I think that's fine, but as long as like you know who it is, that's going to help you. And it's also important that you know what roles you actually need, because we probably needed a technical designer, and we never really approached that topic. So that's important. And you know, don't prototype every single thing. You should first consider that the feature meets your budget, schedule, and your product's promises and values. And I have a note here to sharpen this sword. This is so crucial. This is the sword that you use to slay all the scope creep that could happen. Keep this sharp. Like, keep your team on target with these 3 things, and you won't be making extra code. And also, don't go mad with power when you make a cool tool and you think it's awesome and you want to use it for everything, because you probably don't need to. Anyway, content creation was another problem we had. That's 3.3 here. You know, pipelines are something you should really be thinking about when you're thinking about making a game, especially with lots of playable content that's not just like generated or whatever. So we had this, we had a designer come in eventually, a few months in, right before we got kicked out of the office. And you know, when she came on, the first thing she was doing is like, yo, what is this? This craziness. There's things everywhere. There's objects everywhere. And we were like, uh-oh. And so, our tools weren't conducive to making content. So, we hadn't been making real content up until this point, and we like I showed in the previous picture, we've been programming around it kind of, and all this decomposed data where we had like every single thing be its own little nugget kind of added up to a terrible workflow a lot of the time. So that's kind of how those things got in our way. But as an example, to make a mission in our game, originally each mission was its own scriptable object. You assigned them in the timeline, but you had to edit them separately in their own inspector. If you reused a mission and you changed it somewhere, those changes would propagate throughout the entire timeline. So you had to be sure that you made a new one, and you had to think about, oh, am I using this somewhere else? And you didn't. There was no way to see that. So that was kind of rough. And trying to parse through and assign exactly one of like thousands of mission files was terrible. And coronavirus hit right on time for this because we weren't in the office, and she got these new tools, and our communication kind of broke down a little bit. And we had a lot of trouble identifying there was an issue with this for quite a while. So when we did identify that there was an issue, we started trying to like solve it by trying to organize all these masses of files. So we had like this filters idea. We would like make these palettes that only certain files could be used. But this didn't solve the underlying problem. This just complicated it more. So we kept trying to like stack things on top, but really the problem was architectural at the bottom level. So, continuing from there, we realized we need to increase our communication. So we started setting up meetings every day with no agenda beyond just our kind of stand-up status meeting, because those tend to be, people kind of get in there and just say, oh, I did this, and then they don't really talk about it anymore. So I think we could have approached that one of two ways. We could have like made that meeting more important or opened up a new meeting. We went with the second thing, and it helped a lot. But as soon as we did that, a lot of quality of life improvements started to happen. We added a run button to run the timeline directly from editing it, which saved a lot of time. We added a select parent button, so when you're down deep nested in these timelines, you can go back up, and that was really helpful. We deleted mission asset, this is the big one, and made mission asset embedded within the timeline, because it doesn't make sense not embedded, because it only exists in the scope of that time, right? So here's what that ended up looking like. You selected event type to be mission, and then you can fill out all this data, and there's no need to have a second object involved. You could just set the amount and the types, and you could do that on the fly, and other stuff like different values and stuff. It made this a lot easier to change. And from there, we were able to really make the game a lot quicker. So notes for you. Like I said, you need meetings every day with no agenda. Just like let people just complain loudly at each other, because it's great. Or talk about something that's going well. It's just show up and hang out. You don't get that when you're not in an office, but you need it. So I think it's important, even if you're fully remote right now or you're fully remote always, to set that up for yourselves. And then content-rich games probably need a technical designer. That's something we noticed. You need to think about these workflows early. You don't need to do that late in the game, because the tools are going to be... It takes time to make tools, and it takes time to build the architecture underneath those things, and you got to line that up. And don't go nuts separating data from data. This is the big one, because some things are correct together. Missions should have been embedded in timelines from the get-go, and they didn't make sense separated. And I think there's lots of things that exist like that. And so you got to know where to draw those logical boundaries. So last bit, just some takeaways and happy days for the rest of your siege. What we found with this architecture, some of the advantages that we found, and I think there's a lot of advantages, and we are going to use it continuing forward, was that we could logically group things together a lot easier, and we had really nice change propagation. If we wanted to make changes, we could do it in one place. It integrates really well with custom tools, and we can reuse our code a lot better throughout the project without breaking things. A little bit of a unbeknown to us advantage was less merge conflicts, because now we have all these individual files. When stuff changes, it's less likely that we're going to conflict, and that's less of a headache. And also we can validate all of our data, which is really nice. Normally, that's a little bit more complicated, but if it's its own thing, why not? Some disadvantages that we found where it is really hard to know the logical bounds of a thing. When is something supposed to be one thing or two? And I think that that's a common thing. I don't think that's just to this architecture. Like whenever you're writing code, when does something become something else? When should this be one or two or three things? It's a really important question to hone your ability to answer. You aren't forced to write more tools. Like this doesn't hold your hand and let you do it the easy way. If you do it this way, you're going to need some ways to navigate all this data and all these files. Otherwise, you're going to be in a little bit of trouble. And it's really easy with that same note for your project to become just spaghetti, just like hundreds of files everywhere. And you got to keep a lid on that. Now, at this point, what we're doing is we have a defined file structure based off type, and we just keep everything in there. And that's been helping a lot. But also, you should be aware that like this is not really a disadvantage, but it's just something to note, is that scriptable objects, you really kind of got to manage them a little bit more manually in memory. It's not like things that pop up in a scene. You know, you have to think about when is this getting enabled, when is this getting disabled, when is this loaded, when is it not, and that changes between editor time and build time, and there's some considerations for sure there. We had a lot of memory read problems based off this in our FSM that we had to solve. But I think overall it was still an advantage for us to use it. So if you two go down this road, I suggest these 4 big notes. Communicate, right? Even if you're not using this architecture, it's important that you get people involved early, talk often, and remember that some people project their problems and some people don't. And you should go find the people that don't, and you should ask them what's up. It's important to keep that context for everybody. It's important to separate things logically, keep data away from your systems, and keep your view away from your model. And then sometimes it's appropriate to not separate things. And so I think that is one of the key roles of an engineer in this industry, is where do things stop being the same thing and start being 2 different things. And think about the workflow for making your game. Do that immediately. Oftentimes when you write code, you think about, okay, what's the ideal API to use this? Why not do the same thing for your editor tools? Because that's exactly what you're doing. And also, it's important to eliminate error cases. I think all this kind of boils down to that, which is writing less code and validating your data is going to give you less potential errors. But we also realized, I think something we lacked on this project was testing our systems too. So it's important, I think, and we started doing this now, writing tests for your logic as well as validating your data. And now those 2 things are a lot more testable because they're separated. So I think that's a good thing to do. So thank you. I hope you enjoy the rest of Siege. I'll be answering questions now, and you can follow me at Lazer Bread Ryan on Twitter. And don't forget to vote for the People's Choice Sylvie Awards. I hear there's some really awesome games in there. So
you say potato, I say potato. Thank you, Ryan.
I guess I'll hit the chat. I think I saw a lot of questions.
You say potato, we say potato. Thank you, Ryan. Thanks for joining us.
No problem. Thank you.
Hold on, we got some questions from the YouTubes and the Twitches, so I'll share those first, and hopefully you all can hear me decently. First of all, first question. Oh, by the way, great presentation. Best thing about it, you held 30 people's attention this early in the morning across YouTube and Twitch, so I'm impressed by that. Let's start with Acabalon Etzioni. How big is the game dev community in Alabama? And I hope you talk to him in our Discord too.
Yeah. So our game dev community in Alabama is run. Our local group is called After Hours Game Dev, and it's run by Nick Compton and Lyle Shields, both great guys. And we have about 50 active members on and off, and then we have our Facebook group is like 300 people. So it's actually pretty big. A lot of the Department of Defense work happens out there that's very similar to game development, if not like what I was talking about directly, game development. So a lot of us are out there kind of working on stuff. So it's great. I like it out here.
Very cool. Jesse had a few good questions. So using yield in a coroutine to control when different inputs happen and different things load is what you're suggesting?
Yeah, so it's basically it's almost like use like asynchronous. Like if you ever worked on desktop software, or something, you have like async await. It's the same kind of thing, and coroutines let you do that in a way in Unity that's integrated really nicely, and then it lets you wait for change without having to have a really complicated state machine that you build yourself. So it's kind of like a linear state machine in that way, where it's just states happen and you wait, and then the next thing, and then you wait, and the next thing, and you wait. So we use that pretty extensively. So.
And I know the answer to this next question from Jesse, but I'm going to let you field it anyway.
Okay.
Should this kind of architecture be used for any size game or just mid to large ones?
I think it could be used for any size game. I think tiny games, you'll get a lot of benefit out of doing this because I think honestly, any game that is tiny is going to kind of not be tiny as you work on it. I don't think any game's super tiny. I don't think for a game jam I would do this, because this is really about setting yourself up for success in the coming months. And if you're going to work on this for 2 days, you just slap whatever code. You got to go fast. So I think there's another talk today or tomorrow about game jams, and that would be a good one to go to for that. But yeah, this is more for setting you up for success for a little bit bigger project. But I don't think that there's really it's kind of a soft cap on how small, I would say.
Yes, the game jam success is tomorrow, Sunday. I think that's our noon presentation. But for even individual programmers, developers, if you think your game might be going on for a long time, you want to put these principles into effect. This is the kind of thing that'll save your butt when you come back to it 6 months later.
For sure, yeah.
All right. Let's see if we do maybe one more question before we go into the Discord chat. Artisan JPEG asked, did you have a writer for your missions, or did your designer do that?
I actually wrote a lot of the script, so I did a little bit of creative writing too. Our designer helped me with that. We kind of did it tag teamed. She kind of set up the narrative design of like the overarching, like this is what's going to happen, this is what's involved, and then I wrote all the dialogue and kind of helped with that. So it was very much, the team on this game was actually, I think at the peak, like 5 to 7 people, including production and tech leads and stuff. So very much indie spirit all throughout this, and we did a lot of hat swapping. So I do like that about my job. But yeah, so writing was something that we all kind of tackled a little bit.
Yeah, and for those who wonder about programmer writers, my business partner Ken Leiter, excellent coder, has also written short stories, our game books, and so forth. Yeah, programmers could just never let programmers do the voice acting. That's the one. Never do that. All right.
Well, I'm actually Mo Walters in the game, so if you get to play it.
You get to play Ryan in game.
Yeah.
One comment from Psychic Parrot before we go to Discord. Great talk, loved it. I've used scriptable object architecture for a few projects now, and I'm a fan of it, but still haven't fully tamed it yet.